So that's why I'm not spending too much time on it. But what you guys need to understand is, right now we have 3 pi over 8. And I want you to evaluate for the sine of 3 pi over 8. 3 pi over 8 is not on our unit circle, right? We only have up to 4 to the 4ths, 6ths, and 3rds, and halves, right? We don't have it broken up into 8ths. So we don't have an exact value for 3 pi over 8 by using our unit circle. So if we want to find the exact value, so far what we've talked about is using the sum and difference formulas, right? Remember all those crazy formulas? And when you plug them in, there was a lot of work to do, right? You guys, like, you did one problem, you did 4 of them. I mean, it's a lot of work to do all those sum and difference formulas. So there's another way that we can evaluate for a function 3 pi over 8 if we don't have the value. Rather than doing the sum and difference formulas, we can also use a half angle formula. So what the half angle formula says, if I have sine of half of an angle, that equals plus or minus the square root of 1 minus cosine of that angle divided by 2. So what? Well, let's take a look at it. What I'm saying is, if sine, let's do the sine, or let's say u, or our angle, this is our angle, so we say 3 pi over 8 is equal to u over 2, right? This is equal to that. So to now to find out what u is, you multiply by 2. So therefore, you're going to get 6 pi over 8 equals u.
So whenever we get something like this, we're trying to solve for u.
Mm-hmm. Because in our formula, that's what we have to plug in, right? We have to find the cosine of u. So now let's go and look at it, and we say, OK, so 3 pi over 4. Can we evaluate for 3 pi over 4? Yeah, of course we can. But we need to figure out what the cosine is. So remember 3 pi over 4, 1 pi, 2 pi. It's right there. Negative square root of 2 over 2, comma, square root of 2 over 2. So to find the cosine of that value, we know that the cosine of my u, the cosine of 3 pi over 4, is equal to the x-coordinate, which is negative square root of 2 over 2. So look at that, and we say, all right, so it's plus or minus. And the next thing is, it's going to be plus or minus, but look at where our angle's at. Our angle is u over 2. That's going to provide an angle that's in what quadrant? The second quadrant. So therefore, is sine going to be positive or negative? Positive in the second quadrant. So therefore, we'll keep that as positive. So now it's 1 minus negative square root of 2 over 2 divided by 2. All right? Then what we've learned is to simplify this, to get the 2 off the bottom, we need to multiply by 2 over 2. All right? And then applying distributive property in the numerator, we now obtain a new equation, which equals 2 plus the square root of 2 over 4. Got it? And if you guys remember, the square root of a over b is equal to the square root of a divided by the square root of b. So
Why didn't you just cancel out the 2 and get rid of the
remember, 2 times negative square root of 2 over 2, the 2's are going to divide to 1. So that's why I'm just left with the square root of 2.
No, I'm talking about the denominator.
Yeah, 2 times 2 is 4. No, because that's 2 over 1, and that's really 2 over 1. You're multiplying the 2 on the numerator and multiplying by 2 on the denominator. Yes?
If you cancel out the 2 and the 4, you can get rid of the 2 and then make it 6 and 4.
Cancel out what? Oh, you mean divide these out? Well, you can simplify this to be 1/2 plus pi over 2, or square root of 2 divided by 4. You can't simplify square root of 2 divided by 4 anymore, because there's a. But yeah, you can rewrite that. But before we get to that, if I notice here, what that does is that tells me I can take the square root of my denominator, which I can, which is 2. So my final answer, I'm actually going to rewrite as 2 plus the square root of 2 all over 2. So, I mean, your way, you could still break that up inside of there, but then you could always, take the square root over your 2 as well. Okay? That's it. Done. Can you square a square?